Well, good morning, everyone. I'd like to start by thanking the Farmers for Climate Action for the opportunity to talk with you all today. But I'd also like to acknowledge the contribution made by my colleagues, Dr. Mona Mahoney, Professor Mark Howden, and many other colleagues who've provided intellectual input into the slides that you're going to see today. So I like to start my presentations by giving you two take-home messages. And the first is that there is an undeniable strong correlation between carbon dioxide concentrations and global temperature. So if you look at the top graph there, that is historical observations of global carbon dioxide concentrations and global temperatures. And you can see that the time series goes back to the sort of late 1800s and through to present day. And if you draw a trend line through that, you can see very clearly that the correlation is very strong. So the higher the concentrations of greenhouse gases, the higher the temperatures are at a global scale. So the other take-home message is that there isn't a gradual and slow increase in carbon dioxide concentrations at a global scale. What we are seeing is periods where the accumulation of greenhouse gases have been slow. If you look at that bottom diagram there, you can see that from 1990 to 1999, there was an annual growth of 1.1%. Followed by a period where there was an annual growth of 3.3%, so an acceleration. And then more recently, there was a slowdown, so 2008 to 2017, 1.5%. And more recently, although it's only 2 years of data, so it's too soon to say, but it seems as though we're now starting to go into a period where we're accelerating our emissions once more at a rate at the moment of about 2.7%. So if we look at Australia's contribution, and I do apologise for the small text there, but the top time series shows you the annual rates of accumulation of greenhouse gases in the Australian context. So where the blue line actually sits below the black zero line, that was where emissions were actually going down. And where the blue line sits above that sort of black zero line, that's where emissions have been going up. So certainly over the more recent period, we have a situation where emissions in the Australian context have been growing. And there was a report released very recently by the UN that was fairly concerned about the current trends in Australian emissions, and said that it was unlikely that Australia would meet the Paris carbon emission reduction target of 26 to 28%, given the sort of trends that we're seeing in the accumulation of greenhouse gas emissions. What they did go on to say was that this is a significant issue, that global efforts need to be tripled by 2030 if we are to hold warming below 2 degrees, and ramped up to 5-fold increase if we want to keep below 1.5 degrees. So considerable global effort required to try and keep the emissions down to those levels. What I wanted to show you was the contribution of the emissions to Australia's total. So we have electricity, which is by far contributing the most, followed by stationary energy, then transport, and then finally agriculture. So agriculture has a role in the emissions profile. About 2 weeks ago, there was a report released on the role of land use and in global emissions. And these are some headline statements from that report. If you are interested, if you have a look at that link, apologise for the length of the link, but certainly that is an important sort of piece of information around the contribution of land use and land use change. So what the headline was that 30% of total greenhouse gas emissions are attributed to the entire food system. So between 10 to 12% at the farm gate, and then the rest is actually through the production and manufacturing process. But what they did clearly state was that there was a role for agriculture to play in terms of reducing emissions. And that was through reducing crop and livestock emissions, through sequestering carbon in soils, and also decreasing the emissions intensity of production. And there were some estimates made of the reductions that could be made from agricultural practice of around 1.5 to 4 gigatons of carbon dioxide per year. And that was through soil carbon sequestration and reductions in emissions from fertilizers and methane. So there is a role that agriculture can play. Now, what I wanted to show you here was, at a global scale, what the impacts that historical emissions have already made. So I'm going to turn to my able colleague here. And not happening. Oh, well, that's a shame. What you would have seen was monthly temperature anomalies going back to the 1890s all the way through to present day. And what we would have seen is that at the earlier part of the record, there would have been a balance of hot months and cold months. But as we've moved towards the last two periods there, from the 1980s through to present day, the frequency of cold anomalies, monthly anomalies, has almost disappeared from the global record. And the warm anomalies now are around 2 standard deviations from the long-term mean. So if you can imagine that, and if you are interested, I can show you at a later time today. So as Lynette said, the impacts that we are seeing are really through the temperature extremes. And this map of Australia shows you a comparison of days above 37 degrees between 2 periods. So 1951 to 1980 and 2010 to 2018. And what you can see is undeniably across almost all of the country, the number of days above 37 has increased. If we look at the Australian wheat belt, that figure is between an additional number of days above 37 of between 6 and 14. And in some of those really dark areas, the number of days above 37 has increased to above 20. So 20 more days above 37 degrees in the more recent period compared to the earlier period. What I wanted to do is actually show you what's happened historically for orange. And this is sort of building on what Lynette showed in terms of the distribution of temperatures. So we have, if you think of a bell-shaped curve, we have temperatures which are clustered around that sort of central point, and then we have tails of the distribution. So we have cold tails on the left-hand side and warm tails on the right-hand side. What I'm showing you here is the comparison of 2 different periods. So the blue blobs or the blue bell-shaped curves are 1960 to 1984, and the sort of pinkish bell-shaped curves are 1985 to 2019. So what you can see is that the annual mean minimum temperatures for this orange area have warmed. And in fact, temperatures of 7 to 8 degrees are now 3 times more likely than they were in the earlier part of the record. There's been an increase in the frequency of the annual sort of mean maximum temperatures, although there has been a sort of slight reduction in the sort of warmer end. If we look at the extremes though, these are extreme temperatures you can see ranging from 0 at the warmest end for minimum temperatures down to about -8. And then for the hot temperatures, anything from 30 to about 40 degrees. And so you can see quite clearly in the minimum temperature record for this region, minimum temperatures have warmed considerably. We can do the same thing for rainfall. And what you can see for the orange region is that conditions have dried in the more recent time. And so rainfall events of between 50 and 100 millimeters are now far more frequent than they were in the historical record. What that has led to is a later season break. So we're looking at, for this region, a season break, an autumn season break that is 12 days later than it was in the earlier part of the record. And we're also looking at longer, drier spell lengths in June, July, August, and September, October, November. We've already seen an impact on production or productivity through the historical changes in climate that we've seen. This is some work by a colleague from ABARES that was released in 2017. And what they tried to do in this analysis was actually try to tease out or isolate the climate impacts on productivity across the wheat belt for that period 2000 until 2015. And what they showed was that across the whole of the wheat belt, changes of between 2 and 20%, so a reduction of between 2 and 20% in productivity associated with climate, the changes that we've already seen. That's temperature and rainfall. And so we're already starting to see those changes that we've seen historically translate into productivity changes. How do we make assumptions about what happens into the future? Well, we need models to do that. We don't have another planet that we can go and have a look at and observe, so we rely very much on model simulations. And because we don't have a perfect knowledge of the future, we can't rely on a single scenario, an emission scenario. So when we use our climate models, we have to initialize our climate models with many different scenarios of the future. And you can see here that there's what, 1, 2, 3, 4 sort of main emission scenarios or representative concentration pathways. And depending on which one you follow, you can see at the 2100, you could be anywhere from 0.9 or 1 degree warmer right through to 5.5 degrees warmer if we follow that sort of RCP 8.5 or business as usual, as Lynette said. What we can do is actually track where we're traveling at the moment, because these scenarios were established sort of in the mid-2000s. And what you can see, I think, as Lynette also pointed out, is at the moment we're traveling on that worst case scenario. So that doesn't mean that we'll continue to travel on that, but what it does mean is that we need to make, as global citizens, need to make a concerted effort to try and bring us down to something more like the RCP 2.6. So what we can do is we can examine a range of different climate models, we can examine a range of different emission scenarios, and we can see where there's some consensus or sort of midpoint for scenarios. And this is just a synthesis of projected changes for 2030 for the orange region. So by 2030, on average, so it could be cooler or it could be warmer, temperatures might warm by 0.7 of a degree, so almost a degree warmer than where we currently are today. What this does mean is that that translates to an additional 5 days on average of temperatures above 30 degrees Celsius. What we will also find, though, is that unfortunately annual rainfall will be lower in 2030 than it is across that period 1986 to 2005, and about 5% lower, driven largely by declines in winter and spring. With the warmer temperatures, evaporation is likely to increase as well. So sort of a synthesis for 2030, warmer, slightly drier, but evaporation will be stronger. So this was the tool that Lynette talked about, which is this climate analogues tool. So what we can say is, well, if we were to experience 0.7 of a degree Celsius warming, sort of 5% less annual rainfall, are there analogues, are there geographical analogues in Australia that give us some inclination of what the future will be like? And we can certainly do that exercise. So this is the sort of exercise that I did using that particular tool, the spatial analogues tool. And if you increase orange's temperatures by 0.7 of a degree and reduce annual rainfall by 5%, you can see that the locations there on that list are areas or locations that have that sort of climate condition now. And the thing I would say is that in a lot of those areas, there is viable and commercial agriculture happening. It might be slightly different to what's currently operating in orange, but this sort of exercise starts to give you some idea of what that trajectory of change might actually be. So the question is, given that sort of summary of climate change impacts, how do we adapt? And more importantly, how do we adapt well? So there are a huge number of diverse options. We heard from the first speaker about the range of different adaptation projects that are currently underway. So there are a huge diversity of options. Some of those are on farm, some of those are off farm. Some will be technical, some will be managerial, and importantly, some will be tactical, so small changes to current practice, but some may be transformational, so changing the production entirely. But what I wanted to draw your attention to was this image on the slide, which shows you the difference between two paddocks. And you can see there that there is a considerable difference in terms of cover. And this is because adaptation is highly contextualized and depends very much on the values of the people residing in those areas. And so we have to be cognizant that there is, that adaptation will be highly contextual. Some things that may work in one region or on one farm may not work on another. But we will require a change in the way that we in our knowledge and the way that we act. Here are some examples of tactical adaptation options that are already probably in play to deal with climate variability and reduced rainfall. And the take-home message is that a lot of the adaptation options that are currently being practiced to deal with variability will give resilience to climate change. And so you can see things like zero tillage or minimum disturbance, extending fallows or retaining crop residues, trying to maximise the amount of soil moisture. Also thinking about changing planting decisions to become more opportunistic are ways in which we can adapt to that increased variability that Lynette talked about. This is some examples, or this is an example of tactical adaptation options that came out of a workshop that I participated in very recently, and I know some of you in the room may have participated in this too. So this is looking at the sort of calendar of decisions for sort of livestock and cropping enterprises in the Crookwell and Bannister region. And what came out of that workshop was a tactical way of adapting to this is to take a slightly longer view. So rather than looking at the year as a whole, look at a year and a half or longer and start to make different decisions around the way in which cropping is undertaken and in the way in which livestock is managed. And so that was the sort of ideas that came out of that particular workshop from a tactical perspective. But we do know that we need to move beyond the tactical scale. So tactical adaptation really is small changes to current practice. We need to start thinking more around these sort of systemic and transformational adaptation options. And you can see some examples there of systemic and transformational adaptations. And what we're talking about there is larger changes to the production systems, but associated with those different tiers of adaptation are obviously different risk and different costs. This is an example from the Birchip Cropping Group from some work that I did a few years ago with Harm van Ries, which was a survey that was conducted firstly in 2007, then 2009, 2011 and 2012 with farmers in the region. And it was really to understand what their adaptation journey was. So initially there was an overwhelming focus on tactical adaptation. How can we start to make our systems more robust with small changes? Over time though, as the thinking matured and that journey evolved, then the thinking around farm finance and around more transformational change was actually quite common. So I suppose that the take-home message here is that adaptation to climate change can't be focused just in the tactical scale. We need to think about tactical, systemic, and transformational. Otherwise, if we continue to focus on tactical, we may be maladaptive, or we may only providing a little bit of resilience to further small changes in climate. I wanted to sort of do a comparison of Australian agricultural innovation, and wanted to compare the sort of Australia, which is currently ranked 20th, versus the Netherlands and the USA, which are ranked 2nd and 6th respectively. And look at where the innovation focus is for Australia, which is largely in that sort of research domain, and compare that with the Netherlands and the US, which is sort of more in the development and commercialisation, although there is still a research area. But the sort of main difference there is that more of that research and innovation is being developed and implemented and commercialised, which is what makes the difference, I think, between the Netherlands and the USA and Australia. If you look at the number of researchers per million inhabitants, it's a similar figure. And so we can see that what's really driving the difference there is where the innovation focus areas are and the influence on investment. So really to end off the presentation, in addition to climate change, we have these other mega trends in agricultural production that are also going to be driving change in the future. The ones I've highlighted in green are really the ones that will actually aid innovation and actually thinking about aiding adaptation, whereas the ones in red are actually ones that could potentially reduce our ability to innovate. But certainly if we think about global demand for food and fibre, I think the first speaker talked about this, 9.7 billion people by 2050. So 70% increase in global agricultural production required to service that need. We have, in the Asia-Pacific region, 93% of sort of people willing to pay a premium for healthier food options. And that certainly will be driving consumer sort of demand. The other things that are acting sort of against innovation are around the competition for natural resources and the increased variability and volatility of both markets and climate. But certainly the last one there around embracing non-traditional players. So we're starting to see agricultural, ag-tech investments increase very rapidly in the Australian context. So I think this is my last slide. This is really for those of you who are thinking about engaging with people on this issue of climate change. And we know that there are people, there are sort of different parts of the journey in terms of where people's ideologies lie. So we have the sort of conservative ideology on one end of the distribution, and we have the progressive ideology on the other. And certainly there are different ways of engaging and trying to get some contact with those in the sort of conservative ideology versus those in the progressive ideology. So those ways of engaging and having that dialogue are actually quite different. So my very last slide, is an example from a farmer here in New South Wales, Peter Mailer. Some of you may know Peter personally. But Peter's diversified his production now and has become or installed a significant solar array on his farm, taken some of that farm out of cropping. These are his words, these are not my words. He says solar farming is better money, safer money, easier money than farming giving climate change. So here's someone who's already transforming their agricultural production and quite successful. So on that note, I'll thank you for your attention and look forward to some questions at the question and answer session. Thank you very much.